connection of the transformer, and there we have discussed what are the minimum requirement for the parallel connection of the two single phase transformer. Single phase transformer, so far we have pointer. First of all, we have to maintain the voltage ratio same for the both of the transformer, and second uh, the voltage rating of the same of the transformer, and so people are joining in late. Still somebody is knocking for joining. Anando Chakravarti. Anando, where is Ananda now? Yeah, he's here. So we discussed that the along with this polarity of the should be same, and also we discussed those who know the transformer very well, they can easily remember that also we need to have the to maintain the power factor equal for from the both side of the both transformers. We have to maintain the ratio of the leakage reactance to the leakage resistance. That's also should be equal for the both of the transformers. So this we discussed in the earlier class. And also you told me that the polarity you can identify, and you know the polarity test for single phase transformers. But in case of three-phase transformer, another condition is that along with all of this, we have to maintain the vector group. Otherwise, there will be a dead short circuit into the if we do the wrong parallel connection with the wrong vector group. So that's why we need to understand the what is the vector group and how to determine the vector group for a three-phase transformer. So that should be understood basically. This is a part of understanding because you have to do. Being an engineer, you will be the boss of a power plant, so everything will be dictated by you. If you do the that job only, this is the condition is that you have to explain all of this, and all the people will be below you, technical staff, especially the polytechnic diploma holder, ITI. They will do the job, but however, for any mistake, you have to responsible for that. Okay? So you have to guide them. That's the job of an engineer. So for that, you have to know that. You can know that, or you cannot know that. But matter depends on the field of application, or you are uh, doing the job. If you know that, then you can master your subordinate. But if you don't know that, don't understand that, then subordinate will be master for you. They will be master of you. So that's the difference. Okay? So nothing else. Your job will be the quality of the job will be different. This is another thing. So try to learn, try to understand. Don't memorize. Don't be informative because today there is no value for the information because every information is into the Google. Google is the more powerful than you as far as the information gathering sense. So even Google also provide you material for understanding, but that's our hazard because there is a deficiency into the Google. Quality people, quality teacher, quality faculties are not so available that Google can manage the understanding part better way. Okay. So for that, still, as there is a Google, uh, there is a need for the faculty. So I think that there is no There will be no substitute for any faculty for any future course of time, whatever maybe the Google can store. So what I am directly teaching, so that's the impact of that is something else. That's not cannot be uh, obtained from any other kind of format of the teaching. That's also PowerPoint teaching also today are developing. So many teachers are doing that job with the help of the PowerPoint, but that's also powerful, but only for the derivation side, only for the numerical problems. But as far as the understanding part, we have to do this directly. So that is, I'll do the both things. I will also go for the PowerPoint because it will be needed to complete the course. Otherwise, I will not be able to complete the course. But as far as the understanding part is concerned, and as far as the development of the foundation for a course, I have to take this method, pen, tablet, or digital book. After which, when I will find that you have already got the some basic idea onto the three-phase transformer, so then I can leave it. I can go for the PowerPoint description or the PowerPoint presentation, and that is information part. Understanding part is there, but as you have got the enough foundation on the subject, so you can then proceed by alone. So that will be done. So don't forget that it will be like that. So today, what we have to do, we have to do the parallel operation of the three-phase transformer. Today date is how much? What is the date? 04 March 03 21. So this is the date. We will do the parallel operation, parallel of the transformer, three-phase transformer, three-phase transformer. So that has to be done. Okay. So already 1, 2, 3 already conditions. So here we have to maintain the vector group. Okay? Vector group. So vector groups are important for the three-phase transformer. So we can try it for a transformer. That's not a suppose a y. Suppose a y y the 11 and the dy 1 ought to be in parallel. So if we understand this, what are the problem, then you can understand. Okay. So actually in parallel connections. Okay. So that's it. So first we draw them. Okay, so that we can understand. We will draw the vector group. Okay. So vector group we can draw by phasor. We can draw with phasors. Okay. We can draw the phasors so that we can find the difficulty. So here into the first part YD1, what is the already we have taught? Can you give me the information? What we have taught? How to draw the YD1? So first of all, you can consider a phase sequence is like this. Okay, phase sequence is A B C. If we consider the phase sequence is A B C. Then you can draw the, first of all, Y is the high voltage side. So we can draw the A phase here. So A phase, we can name it as A2, A1. Two terminal already will be there. So accordingly, we can name the Y. So as the phase sequence is ABC, what will be this one? Hello. What will be this phase? B1 and B2. Okay, you can terminal the both terminal is this, and there will be another phase that is called the C2, C1. Okay. What is the phase here for the delta? For it is Y side. What will be in delta side? Hello, D11. So we can draw it. This will be like this: the delta side A1 and A2, and then this will be the you can say this will be the B1 and the B2, and this will be the C1 and C2. So, so you say that the what is the YD1, YD11. So now from this we can say that it is a YD11. So here is the 11. Okay, so that's called the 11. Now what are the tasks? So this is the vector group. So similarly dy1, you can draw the dy1 here. So if we draw the dy1, then what will be the vector group? First we draw the y1, okay, small letter. So can you draw the y1? Hello. What will be y1? So y1 means this will be address the 1. So this will be a1 and a2. Then obviously this will be then the b1 and b2. And this will be the c1 and c2 phasor. Okay, winding we are not drawing the winding because winding is will be the exact replica of the phasor. So phasor is we are drawing. So winding also can be drawn, but that's not needed for as far as the understanding. So I will say that you have to imagine that phasor means a winding is there, and here arrow is A2, so A2, B2, and C2 are the positive terminals of these conditions. So whatever may be Y conditions. So now if it is a Y, so then D will be drawn very convenient way. So then for this, D will be like this. This will be the A1 and A2, and this will be the C. You can say that this will be the C2 C1, and this will be the B1 B2. So these are the two transformers. So can you say if we do the parallel of these two transformers, what will be the problem for it? Hello, anybody is here or everyone has left the stage?
Yes, sir, we are
Uh,
here.
oh, you are here. Okay, thank you. Some so somebody has to take the this on that how to if we do the parallel. So of this parallel means primary we can do the parallel. Okay, but what will be the problem in secondary? Because you can see that in primary line to line voltage here is like this. This is the line to line voltage. This is also line to line voltage. So this is also line to line voltage. So these are called the line voltage. Here also you see that both line are same. So this is also the line voltage. So as far as the line voltage is concerned, all are in symmetrical. So we can do the parallel in primary. So there is no problem in parallel in primary. So you can do the primary in parallel. So primary can be in parallel. In parallel. So what will be problem for secondary? Okay. So there will be problem in parallel operation. So what will be the problem in secondary if we do the secondary? So can you identify what are the line voltage of the secondary? Similarly, line voltage of the primaries are identical because these line voltage are identical with this. So there will be no problem. And but whatever the line voltage of the these one, so this is the line voltage. Okay? Line voltage of the secondary. So what are the line voltage of the corresponding here? Can you say what is the terminal here? The terminal here is C2 and here it is A2. So what are the line voltage between this? This is the line voltage between C2 and A2. Okay. So what will be similarly line voltage here for this transformer? This will be the line voltage. So if these two line voltage are dissimilar, so now if we make A2 parallel, if we make short of A2 and A2 and B2 and B2 and C2 and C2 of both the secondary of transformers, what will be problem?
Sir, internally high circulating current will be there.
So problem is that they are line voltage, as these are giving the line voltage. Okay, so this one is giving between the these are giving the line voltage. Okay, these are giving the line voltage. So these are called the line. But line voltage of the both transformer are different. So line voltage of secondary line voltage of YD11 and and DY1, what is the phase difference? Phase difference
30 degree.
40 degree. So we can say that the line
No, sir,
voltage
60
of
degree I think 60 degrees. Sorry, I think 60 degree.
so phase difference is 60 degree. Sorry, yeah. So YD11 phasor line is leading than DY1 by how much?
60 degree.
60 degree. So if we draw that, so what will be case for the secondary? So this will be the line voltage of the C2 A2 of YD11, and then this will be the line voltage of DY1. Okay, so there is an angle between them is how much? 60 degrees. So this is also equal. So this is for T1, this is for T2. So what is the problem if we make the short? So you see that what is the problem?
Yes,
so
sir.
There will be a great problem. One line difference means other line also will be similarly displaced. Okay. So both lines are all lines will be. See, this is one line has been shown. So there are three lines. So we cannot do the parallel like this. So we cannot do the parallel. So then what we do? So Whether we can do or not, so that depends on the some modification. Some modification, what we can do. Suppose uh, if we make this uh, secondary of this, okay, with the secondary of this similar, then we can have the same phase of the line voltage. So that means the 60 degree for doing parallel, for doing parallel, we have to make this 60 degree to 0 degree. Okay, so that's our task. Do you understand that?
Yes, sir.
Otherwise, we can't do the parallel operation. So that's our task. So we have to do the parallel. So anyone can be changed. Okay. So we can change the anyone. So we can change the anyone. So what we do? So we start with the dy1. Okay. So now we start with this modification dy1. Suppose dy1 we have to modify. So what was the phasor? Phasor was this dy1. So the secondary you can draw. Okay. Secondary, if we draw the dy1 secondary, that was the primary. We can draw it. It is the primary. So in dy1, what was the? This is so a2. Okay. This is a1. Have you got this? So this is very positive. So thereby we have applied. This is a. Okay. So then this was the B1. Phase sequence is ABC. This was the B2. So this line is B. Can we say that? Hello. Can we say for Y dy1? So this line was C2 and this line was C1. So this is the dot polarity. And so these are the C. So these are the lines. Okay. And for these lines, what we obtained the secondary is like this. A1, A2, and the B1, B2, and the uh, C1, C2. This is the Y side. Okay. So now if we change there, okay, supply side. Okay. So if we change the supply like this, so instead of so if we do uh, uh, if
Sir,
we
ACB
do
phase sequence.
no, if we do plus terminal shifting, sorry, if we do input line terminals shifting like this, in place of A, C, in place of B, A, in place of C, sorry, hello. In place of, sorry, train is disturbing. In place of C, B, can we do this? We are shifting this one. This input line, this is coming from here, okay? ABC. So ABC, sorry, ACB. So in place of A, we are connecting C. In place of B, we are connecting like that. So then what will be the phasor, secondary phasor? Can you say? What will be then the modification? So secondary, now secondary site is like this. So now this one will be, what will be this one? Can you say, if we do the change of these lines, can we say this one will be C1, C2? Hello. Because instead of A, we have connected C line. Can we say that? Hello.
Yes, sir.
So in place of A, input terminal has been changed. So there C has been connected. So thereby the here now instead of A phasor, which phasor will appear? C phasor will appear. Okay. So that is the change. Similarly, here, what will be the here? It will be A1, A1, A2, and it will be B1, B2. So there is a modification. Now, if we connect them, this delta, so what will be the delta ending? Now, this Y, this Y side terminals of the windings are in reverse star. Okay. Earlier it was the star. Okay. Now what is the reverse star? Reverse star will be like this. So this will be the C1. This side will be C2. Can we write it? This will be the B2. This will be the B1. And this will be the A2. This will be the A1. If we interchange the terminals, so that means earlier here winding was like this. Okay. This side is this C2, this side is C1, and this side was the A1, and this side was the A2. Now this side is B1, this side is B2. This is for the this one. Okay. Now for this, what we have connected? For this, we have connected this one as a B2. This is B1, and this one is C1. C1. This is C2, and this side is A2, A1. So now, instead of this, if we do this type of connection, then phasor, can we say that this phasor will arise? So this is giving this phasor, this will give this phasor. Can we say that? Do you understand this point? Hello. Do you understand this point? We have changed the star connection in reverse of the winding. Reverse star. And so, what is the phasor now? You see that. So this is the now the of the secondary C and A phasor. Okay, and this is the line for same dy1. So now what is the earlier phasor was is this C and A. Can we do now parallel? So as the secondary lines are in the same phase, so as now the secondary of both uh, phasors, that is line, are in same phase, so we can do now in parallel. So this is called the modification. So thus we can do the parallel operation after modification. Some interchange of the connections basically and the terminals. So we do the parallel operation of this. So now these will have to be explained. So what I have done, that is YD, we have done Y D11 and DY1. So can we do now the same thing as a YD1 and the DY11? So do it. So you have to do this one, okay? So you have to do this one, practice this one. Then we can do the parallel operations of this transformer. And now how to test the vector group of a transformer. So if we test the vector group of a transformer, vector group testing. So the connection of the vector group test of the different transformer is different. So suppose we have to test the YY0. So how can you do this? How can you do this? That is very simple. So we do the like this a phasor of this, a similar phase sequence. So this will be the A, this will be the B, this will be the C of the Y connection, and similarly this will be the A, this will be the B, and this will be the C of the same connection. So windings. So what we can do that we can make the sort of this one line to neutral. So this is called the neutral. This is also called the neutral. So then how to superimpose this? So if we do this, then this will form the voltage like this. You can say that it will be superposition of this, where you see this will be A, this will be B, this will be C. So what we have done here, connection is here. So this is the connection diagram. A, B. So that's the we have done. So what will be voltage between the neutral to this point? Okay. So if we maintain a voltmeter here from here, so the here, what will be the reading of the voltmeter? And if we do the voltmeter from here to here, so what will be reading of this? So that reading will show us what is the condition of this. So vectorically, if we do this voltmeter from here to here, what will be the result? Hello, or between A and capital A, what will be the reading of the voltmeter reading? Uh, voltmeter, voltmeter meter reading. What will be voltmeter reading between capital A and small a? So voltmeter reading of the so if they are summing, summation is there, okay. Sum, then it will be the y 0. If there is any difference, then it will be y 6. So thus we can find the vector group. So this is the way you can find the vector group. So you have to do the connection for it is y connection. Now if it is a connection is different, suppose connection is uh, b y1 or 11, then how to make the connection? You have to make the connection. So that you can do that. So this will be the A, and then this will be the B, and then this will be the C. Okay. Similarly, here it will be this will be the small a, this will be the small b, this will be the small c. Now, how to make this the vector group test? This is also you have to do. You can short the winding here. Okay? You can short the winding here. Then you can measure the voltage from B to C and the voltage between B to B, and similarly voltage between C to C and the B to C to B. So thus you can identify and what is the phasor vector group. So this is the connection you have to read, and vectorically you have to see what the resultant should come and what the voltmeter is giving. So that's why this is the another vector group test. Okay, vector group test of the vector group test of the transformer. So thus each transformer connection should have a different vector group so that you can understand this one. Okay. So this is a wall for the parallel operation and vector group. Now we will go for the zigzag connection of the transformer. One connection of the zigzag transformer, we will see that what is the zigzag connection. Zigzag connection of the transformer. So here the secondary or primary is a single winding, but secondary will have two windings for each phase with equal rating. Okay, with equal rating. So thereby, if we have a primary, suppose a uh, y uh, y. Okay. So what will be then the primary? Primary will be like this. Finding like this. So this will be y. Y z. Okay. So in that case, uh, it will be A, it will be B, it will be C. Or in case of Z, we will have the two windings. One is the A3, A4, another will have the A1, A2, and similarly another will have the B will be two winding, and this will be the 1, 2, this will be the B3 and B4, and all will be dot here. Polarity of this will be like this. Okay. And here we will have the C1 and C2 and the C3, C4. So these are the polarity of the jet connections. Now if we draw the phasor, then what is the phasor is there? This is the A phasor, this is the B phasor, and this is the C phasor. C phasor. And here also we can draw the phasor. This is the A4, 3, and this is the A2, 1, and this is the phasor of B1, 2. This is the phasor of B3, 4. Now this will be the phasor of C1, 2, and this is the phasor of C4, 3. So these are the phasors of the secondary side. Now if you want to connect it as a YZ star, 11. Suppose we want to make it as a YZ 11. Can we make it? Hello. So that's the task. So Z side we can make as 11. So any suppose though we can do the 11 like this. We can do the like this. Okay, this is the A1, 2. This is the B1, 2. This is the C1. Sorry, 2, 1. So thus, now if we want to make the 11, can we do this? Uh, So what we have to do, first portion is we have to connect this as a reverse way, okay. So one side of the winding, if we do the connection like this, okay, first we do the connection for understanding this one, otherwise you cannot understand. Suppose we are doing the connection like this, suppose we are doing connection, so we are doing a connection like this. So what does it mean? We are connecting the two terminal here, one terminal here, it is A. We are connecting two terminal here and one terminal here, it is for C. We are connecting the two terminal here, one terminal here, it is for B. Now we are connecting winding is like this, that is connecting A, here 3, here 4. And here also you are connecting the winding like this, B, it is a 3, it is a 4. Now we are connecting here C like this, it is a 3, 4, it is a 3, 4, 3. So now you see that this line is C, this line is B, but this line is A. So what is the now phase? So now you see that phase has become like this. So here we can say that phase voltage is like this. This is the phase voltage of the A. This is the phase voltage of the B, and this is the phase voltage of the C. So that has become YZ11. Okay, so we can write. So Y here, similarly, Y is here, same Y, A, B, C. But here we will say that 11 has become, this is the 11. So same A here is this, here is B at 11. You can see that these are called the phase voltage. Phase voltage. So here also the phase voltage. So that is the change of YZ 11. So similarly, if we want to do hello, have you got it? YZ 11. How we can find the YZ 11? So one connection is enough for understanding. So how we have made it? So YZ 11. This is called the zigzag connections. So these are called the zigzag connections. So these are called the zigzag connections. Zigzag, zigzag connections. So these are called the zigzag connections of the transformer. So thus we can make the zigzag connection of the transformer. So similarly, various connection we can make. So now we will go for the so various connection we can make with this, so that we can do the we can do the various connection diagrams from this. So you can do the various connection diagrams. So that uh, So here we can find the various connections of the transformer already we have discussed. So connection YY0, DD0, similarly connection DZ0. Already we have discussed what is zigzag connection. So similarly we can do DZ0 also. Okay, what will be the DZ0? And similarly YY6, we have seen the what is YY6, and then the DD6 we have also observed, and then DZ6. So how to make them the DZ6? One example has been done. Similarly, other connection also we have found DY1 and YD1 and YZ1. So DY11 and the YD11. So DZ11. So these are the connections. So from these we can say that this will be the connection for this. Uh, so we can do that. Oh, the first section, अच्छा, also section.